The general process of the knowledge discovery. Okay, so I already explained a million times. From the database, when we have the source of the data from the databases, so we try to first integrate the different sources, data from the different sources. The most of the KDD, the knowledge discovery or the data mining technique require data cleaning. Data cleaning means we will see the details in the chapter 3 after the math, the review of the math. At the time we will talk about the data itself, but the data cleaning means, so sometimes the data in the relational database is a very clean data, which means it's a well-structured data. We don't have to worry about the purity of the data because it's already fit to the data structure. However, sometimes when we process the data for data mining or the knowledge discovery, we have some missing data or sometimes the garbage data, sometimes unexpected data, or the data are not well formatted, well not structured. So we need to remove such a noise data. Also we need to consider such a missing data. Also we need to make the certain format of the data. That's called the data cleaning part. Then finally we can have the data warehousing that I mentioned from the different data sources. So we have a very large data. Then we can actually extract some the test relevant data. We don't need sometimes all of the data. We can focus on the specific types of the data. Then finally we can apply the data mining technique. At that time, the first time when we implement the data warehousing, it was the OLAP or the business intelligence. But overall, it's called the data mining technique. Then finally, we can have the certain knowledge, or it can be the kind of the pattern. It doesn't matter. Then we need to evaluate whether this knowledge, this pattern is correct or not. That is the pattern evaluation. Sometimes it can be the feedback, okay, and repeatedly processed until we got something the evaluated knowledge. That is the general process of the knowledge discovery. Okay. This is an example of the web mining, which is used a lot nowadays. Okay, so it's a similar process, okay, that emerged from the data cleaning. Usually, it can be most of the data source for the web mining is the web log data. So where is the source and what is the target web page and what is the next and so on. Okay. And then the web mining follow the similar pattern, similar process as the KDD process that we mentioned here. Nowadays, the example of the such a data mining is focusing on the social media data. In the social media data, so we can be classified as several things, but the user profiling is one of the popular one. Mohammed, our GA, he is doing his PhD research on the user profiling, which means, for example, in the Facebook has a very strong policy, which means we don't sometimes, if I block my personal information, you cannot retrieve my information, like where I live, or my gender, or my age, where I work. Okay, but sometimes when you see the profile picture or some of the information that I posted, you probably guess who I am, and what is the age, and what is a favorite sport, and what is the interesting color, or something like that. You can guess, right? That is the user profile. Without the answer, you can actually guess. Then, what is the importance of the user profiling? If you have the business, you can actually target on the specific the group of the user who are interested in the, for example, I'd like to sell the coffee. So if you pop up such a coffee for all the Facebook user, it's a waste of money, right? But if you can find some of the Facebook user who are interested in the coffee, okay, then probably it will be high return ratio. Return ratio means who click this time for that, or eventually buy this product. Okay, that is the goal of the user profiling. Okay, not easy. What he's doing is he is focusing on the gender and some location where they live. So, for example, next one is the user location. Idea of the user location is, for example, if you analyze the, if you see the tweet the message, for example, there are a lot of the word like the Manhattan or the New York. Probably the user will be around the New York area, right? Probably not in the California, not in the Asian country. So by analyzing such a tweet message, you can guess where the user lives. Okay, that is the user profiling and location. Like the other demographic information, like the age or something, the family size and how many children and whether Asian or not. Okay, and trend, the what the trend of the flu or something other information. So let's take a look at the video. Even sentimental analysis, one of the important application of such a data analytics, like whether I own the IBM, and whether IBM is good reputation or bad reputation nowadays. How can you do that? So we have the group of the word that represent good and we have the group of word for bad. So we will count how many of them. Even such a system does not use a very complicated algorithm. Sometimes just the simple count number of words. Okay, so then they can actually use such a system for marketing or some other event. So this is the example of the social user mining. And the data mining in business intelligence. So how data mining technique can be used in the business. So similar, but finally it can be used for decision making. Okay, that is different. So whether we go for this business or not. So like that. Okay. The others are quite similar that you can understand. That data and data analysis. This is by person. So database administrator is up to this part. Okay, but above that, in addition to the knowledge of this one, it needs something analytical ability. But here, end user means decision maker, like the CEO in the company. In terms of the machine learning or statistics, how can we see the KDD process? But data mining is used for the in-between pre-processing and post-processing, and finally output is the pattern. So I already explained. Okay. So what is the difference anyway? Such a traditional data analyst or the traditional data mining and current one. The main different thing is the size of the data. Nowadays we can deal with the huge amount of the data, trillions of the transaction at the same time, or the petabyte size data, or sometimes exabyte size of the data with the depth of the supercomputing power. As always, nowadays we have the big data solution, for example, the Hadoop system and something like that. Then on top of such a Hadoop system, we can implement the data mining technique. So we will actually see one time the data mining for the Hadoop system. So Mauhao. The name of the Indian, the philosopher, I think. Right? Mauhao. So the name of that system, right? So Mauhao. So data mining tech tool for based on the Hadoop system. Usually Hadoop component has the weird name. Most of them are animal. But anyway, so we will see. That's another thing that I'm going to add in this semester. We will see the Hadoop-based data mining tool also. Also, mostly it's a high-dimensional data. So more and more, higher and higher dimensional data. The main problem of the high-dimensional data is curse of the dimensionality. So what is a dimension? Dimension or dimension. Dimension means the number of elements to explain about the feature. Like for example, the simple example is this is the Gaussian x and y coordinate space. So if you have the certain point, this is the item, this is the data. It doesn't matter. So we call that this is a data. This data can be represented by x and y value. So at that time we can say this is a two-dimensional data. If we have something like this x, y, z, when you have the data, this is x, y, z, it's a three-dimensional data. So, for example, you have the data item for Facebook user. That user one can be represented by name, ID, and the message. Sometimes 100 feature. You can consider such a feature or the attribute as the column in the database system, okay, table. So you have a huge amount of dimensions, sometimes 100, 200, so more than that, okay. Nowadays it's a much bigger dimension. When you have such a high dimensional data, when you compare user 1 and user 2, clearly different user. This user is, for example, man, this is a woman, but the others are quite similar. So if you equally consider each and every feature dimension, this user and this user are almost the same. Even though the main characteristic gender is different. This is called curse of the dimensionality. Because of a high dimension, such a different characteristic will be hidden by the other feature. So we need to consider different approach to deal with such a high dimensional data. So for example here, x and y, x1, y1, x2, y2. How can you compute the distance? You can use the Euclidean distance, x2 minus x1 square, y2 minus y1 square, and this is a Euclidean distance. However, if you consider exactly same, the Euclidean distance here, no, you cannot distinguish the difference. That's the problem of the high dimensional data. At that time, one of the approaches, if not much it's not important, so you can eliminate. This is called the primary component analysis. It's a PCA. You try to find primary component, primary feature, okay? Or you can find it whether they are correlated. If this one correlated, you can consider them, all of them as one feature. Okay, something like that. So that is a characteristic of such a high dimensional data. This is a characteristic nowadays. Also, complexity is higher and higher. Okay, sometimes the sensor data is keep sending the data periodically. Okay, from the bunch of different sensors. Also, time series data is along the time you can have the something data like the stock price. Stock price is from 9 a.m. to 3 p.m. It's a time series data. If you can find similar pattern from the past, 1 year ago, one of the stock price has exactly same pattern. Next day is usually going up. So we can use this one to guess the next day going on. Can we match this time series data and this time series data? Or can we find the frequent pattern? That's not easy, actually. So that is the time series data. Also sometimes called the temporal data or sequence data. It's the same meaning. Sequence data, example of the sequence data is what? Video sequence. Video sequence is related. So sequence. So that is more complex data. Also nowadays the graph or social network data. So based on, for example, Facebook user. So I'm friend with this. user, okay? Then this user has the friend like this one, and so we have another user. We can find there are 3 power users, something like that, or the group. So there are 3 community. If we just consider each user as the user table, okay, or relation table, like the relational approach, we cannot find such a characteristic. By using graph, we can easily identify such a different group or different such a characteristic of the data. So heterogeneous database means data sources are different nowadays. Some of the data from the relational database, some of the data from web log, some of the data from the sensor data. So how can we fuse, how can we combine such a different source of the data are also very critical. Also some of the data are special characteristics, like the GIS information. Also, even when I take the photo, it has the X and Y coordinate value. By analyzing such a X and Y coordinate value or spatial information, we can find a bunch of important information, right? I think I already explained many of them. Okay. So it's a different view of the data mining. So I already explained the history of the data mining. So there is different view. And some of the important thing is I'd like to mention that the descriptive versus predictive data mining. Descriptive is the statistic. Describe the current characteristic. That's also important. I do not mean the descriptive is less important than predictive. No, it's also important. Even it's hard to see the current, the characteristic of the data. At that time, we need the help of such a statistics. But nowadays, the predictive is attractive a lot. Whether this data is going up, this data is going down. Okay, what is the next? That is a predictive. Okay. What kind of data we can use for data mining? So it's not only the relational database model is a good source of the data mining because it's well organized already. But the problem is it has a specific purpose. Also, it's well organized. Well organized means it's not flexible to handle it because it data already fit to the specific requirement, like through the data modeling. So very limited to process such a data. So we can use something data warehouse or the transactional data to mine such a data. However, in addition to that, there are more and more flexible data sources like the data streams. Nowadays, streaming data is also important. Think about the Twitter message is kind of streaming data sometimes. Along the time, keep sending the tweet, or even the one tweet, the message can be retweet. If we can analyze such a pattern of the retweet, because that is the power of social media data. Still, text-based information are most important to be mined, because text data itself has the meaning of the data. Okay, if we can find something, frequent word, good, bad. Bad itself has the meaning, good itself has the meaning. So we can get the more information from the meaning of such a word, text information. However, think about the multimedia data. So, for example, when you see the web pages, sometimes one image image explain much better than the huge amount of the text data. In other words, if we can analyze the image data and video data, visual information such as multimedia data, we can find more valuable information. However, that is out of scope in this class. We are not going to deal with such a multimedia data base. Instead, I'm offering the multimedia database course, usually 4th semester. More difficult, right? Yeah. So we did, for example, the project to follow the lane. Okay, it's captured by the camera on the drone. Even there are a bunch of different variables, so it's not easy. So, data mining function, okay, so I think that I explained the most of them, so we can quickly go over. So if we can generalize, that is the knowledge. This is actually the human thinking process is consisting of the generalization and specialization. If we can generalize, this is a bottle, this is another bottle, this is another bottle. Bottle is like the cylinder shape. Sometimes it's not the clear cylinder. It can be the wave or it has a bottle. So then we can generalize. This is the bottle. Then when we see the new bottle, so we can specialize it. Okay, that is the knowledge. So generalized one is also knowledge. So that is the generalization. Okay, or summarize. Sometimes it's called the summarize. Okay. Association or the correlation. If two items are related, then that is a kind of pair. So this is one of the examples that I explained what is frequently purchased together in your Walmart. The diaper and beer. This is very, very well known. It's actually the first practical example of the association with mining. So it has been used a lot as an example. Because first time when you see the diaper and beer, it looks like weird, the match. But after we see the example, you can understand why this kind of thing happens. Classification, as I explained, is a label, the prediction. So we had the rule or the label or something trained data. Using such a rule, we can classify, make the group of the data. Okay? So usually at the time we need something based on using something. So for example, classify the country using the climate, or sometimes classify the car based on the gas mileage. We have the rule. The problem is, how can we find, how can we determine such a rule? That is the key point when we are doing such a classification. So our typical method of such a classification is a decision tree. You probably heard about such a decision tree. When you build a decision tree, what is the rule to decide this one? So we will see such a decision tree or Bayesian classification. Bayesian classification, we will see what is a Bayes rule, what is a Bayesian. Bayesian is usually conditional probability. You know what is a probability? When you toss the coin, okay? So what is the chance? What is the probability of the tail? It's a 50%, right? When you have the 3 black and the 4 white, what is the chance of the 3 to pick it up? So 3 out of 7. However, if you take out the first, you take 1 and the second you take out, and what is the probability of the pick out the two same color, something like that. Then at the time it will be related to the previous one. Okay, that is a conditional probability. So Bayesian classification is based on the conditional probability. Support vector machine is one of the classification and also can be considered as the clustering, which is the most popular, okay, and most used the classification method. Neural network is a little bit old technology because it's slow and hard to form such a network. So nowadays, not many applications use, but still you probably heard about the neural network a lot from old research. So 10 years ago, 20 years ago, they used the neural network is the most popular, and many of them use. But nowadays, you may not see such a neural network based approach. Rule-based classification, most practical solution. Once you have the rules. So the problem is the rule has been changed a lot along the time. Okay? And pattern-based classification and logistic regression. Regression is deal with in statistics. Okay? So still used a lot in the practical solution, such as regression. The application, fraud detection. You probably ever faced such a problem. Your credit card doesn't work.
Yeah.
Sometimes if you travel to the West Coast, then if you try to use them, it's blocked. Then you need to call. Then they explain that I'm the owner of this card and I'm traveling. Or before you travel, you need to inform them. Otherwise, you cannot use because they have the certain rules or classification, whether this transaction is valid or not, whether this is a fraud or not. Okay? Also, DM, direct marketing, so when they send something, the flyer, advertisement, okay, at the time, so if I'd like to focus on the middle class and who lives around the Fairfield area, then they send the advertisement, directed marketing, and so on. Clustering is the unsupervised learning. Okay, so we need to group of the data using data itself. There's no other rule. There's no other help than label. Using such a classification and clustering, if we can use such output of the data to detect the outlier. Outlier means it's an exception or out of the data. For example, this is our cluster and another cluster or another group. If I have the data like here, this is called the outlier. This is an exception case. This is something wrong. So if we can find this one, that is used for something very useful application. One of the examples using such a outlier is I used such a technique for the video processing. In video processing, so we can find the moving pattern. So people are walking this way, this way, this way. Usually, this is the whole way. Then, if there is something pattern like this is something wrong, outlier. Then it can the alarm like that. Or if somebody is fighting in the middle, there are a lot of movement in the middle. That is also the false alarm, and that is alarm for outlier. So, problem is whether this is a noise or whether this is inside valid or not. Okay. Nowadays, as I explained before, sequential, the time or ordering sequential pattern, those are important. And because the data structure are complex and more complex, like the graph mining, it's not easy. Because graph data itself, most of the graph theory is a non-polynomial, NP-hard. There's no optimization. It's an NP-hard problem, many of them. So it's not easy, but still it's useful. So we can use graph data mining to handle such a social media data. Okay. And also web mining is nowadays used a lot. Even there exists a course that you read only the web mining. Another important part of the data mining is once we got the output, so we have the knowledge, we have the output of the data mining. So this is our cluster, or this is our pattern. So I try to predict the next step. Yeah. Is it correct or not? You need to evaluate. Okay. However, if you have something answer, then it's easy to evaluate. But not always you have the answer. For example, I have the algorithm, data mining algorithm, to determine whether this user is the 20 years old, 30 years old, or 40 years old. But where can I get such a data? There's no way to prove. So because the Facebook never released such a data. So sometimes it's not easy to evaluate the pattern or knowledge that you discover. Also, how can you prove? Sometimes it can be, if you can represent such output of the evaluation as the accuracy, that's good. Okay, it's a nice case and lucky case, but sometimes not always. Okay. So data mining. So I already explained about the machine learning and the data mining relationship, and also it can be considered as a pattern recognition. Also, definitely it uses the statistics, and it requires high performance computing to deal with the big data, and also it is actually from the database technology. Data mining itself actually the algorithm, and it can have a lot of application. Another important aspect of the data mining you can focus on, and also it's a kind of another opportunity after graduation, it's the visualization. So nowadays the visualization is not just to display the data. It can be used for the tool for data mining. So for example, simple example is, so when I write down this sequence of number, nothing special, right? But if I can line up this number in the lane, like this one, 1, 2, 3, 1, 2, and 10, 11, 12, you can clearly see there are two groups. This is a simple idea to show the benefit of the visualization. So nowadays the visualization is used a lot. Even though you don't have to process the data. Using just the visualized data, you can find a lot of information. For example, such a graph is also another example. Using graph visualization, you can get more insight, the information. So that is the power of the visualization. It's a very new area of the data mining. So we will see a little bit about the visualization using R program. One of the benefits, the power of the strength of the R programming is for visualization. Very easy, it supports a lot of nice and fancy visualization. issues. Okay. So it's not that simple. The association rule or the frequent pattern. Nowadays, our knowledge pattern itself is more and more complex. So we don't know what we need to do, or what is the possible output when we apply the data mining technique to the data. So that's one of the issues. And definitely, as I mentioned before, the mining the multi-dimensional space is more challenging. Okay. Also, sometimes you don't understand the data itself. It's hard. For example, he's doing research on the RNA, DNA. It's a DNA data. First, you need to know what AGCP means, right? What is the pattern? What kind of pattern that the medical doctor or the data expertise are interested in? You need to know such a thing. So it's an interdisciplinary effort. Sometimes you need to work with the domain expert. Okay. Also, nowadays the data are not very clean, which means it has a lot of noise data, uncertain data, and incompleteness data. You need to, sometimes you can pre-process such a data to make it better, not always. In your algorithm, you need to consider such an incompleteness of the data. Okay. Also, it's true. It cannot be 100% automated system. Sometimes for better accuracy, user should be intervened, which means user interaction like the feedback based. So if you, once you got the result, you decide, label, this is correct, this is not correct, this is correct, then run it again based on your feedback. Until there is no change or until user satisfied. That is a user feedback, user interaction. That's more practical solution nowadays. What's the scalability? What if we have the more data? So your algorithm is perfect with this amount of data. But when you have the double size or the 10 or the more size, it takes 10 days. It cannot be scalable. So we need to consider. Sometimes it can be solved by the algorithm, but sometimes we can add the power, the hardware. Okay. And as you know, it's social impact of the data mining. It can affect more and more. But it poses the privacy issue. What if I find all the private information, like I don't want to release my information, but using data mining solution, so everybody can find my information. Is it private? Is it the legal? Is it illegal? That's the issue also. Okay, so these are the textbook provided very nice reference. So if you wanna see the details about the topic, so you can find the paper. The best way, copy and paste this one to the Google search. Most of the case, 90% you can find the paper. That paper. If you cannot find the paper, why don't you go to the Eureka, which is a library search system. Most of the time you can find that. If you cannot find the paper, you can actually find the author of this paper, then find the email, then email to them. They usually respond if they are available. Okay, that's the end of the chapter and also end of today's lecture. So next week I will finish we'll cover the chapter 2 also then, followed by the math, the review of the math. Okay.